Hello there. Right, this is a video about using an old HP-11C or one of the newer recreations of it for a GCSE Maths paper. And I don't really know, I don't know exactly why I wanted to do this video, but I can think of a few reasons why it's kind of interesting. So number one is, do you think, is it actually allowed? Could you use one of these for GCSE? So I'll address that first. Secondly, is it a good idea? You're going to run into any problems? Are there things that, this 40, 50-year-old technology is just not going to be able to do? And thirdly, if you're at all interested in RPN, you might find it interesting just to see how you can approach problems with it. Anyway, I originally wanted to do this sight unseen, but I found out that actually the example papers that I got from the website are all kind of a bit similar. I didn't notice that you've got this difference between higher tier and foundation tier, for example. So I did try and record a video, and then I actually got stuck on a question and it just didn't make for a good video. So yeah, I have seen most of these examples, so it doesn't mean that I won't still make a mistake. So first question is, could you use this in a UK GCSE exam? Well, basically, it's the JCQ, or Joint Council for Qualifications, are the people who basically say what kind of calculators are allowed. What I'll do, I don't know if I can, yeah, I can zoom in a bit, there we go. So this is their advice. It's in section 10 of their, I think it's called exam use regulations or something like that. I'll put a link in to the description. Right, and then we can have a look through it. So it's quite clear, really. Using calculators. So it's defined as an electronic device whose primary purpose is to carry out mathematical calculations. So that excludes anything that is basically a computer or phone. So tick for that. So so this is published guidance calculated, but it may be varied by the awarding body. So you do have to check who you're doing your exams with. So it will say whether on the paper whether calculators are allowed or not. That's a really important point, because they're not allowed on the non-calculator GCSE Maths paper. Where the use of calculators is allowed, the candidates are responsible that it meets the awarding body's regulations. So they do emphasise that it's about the awarding body. Right, so this is where it gets a bit more explicit. During an examination, calculator must not offer any of these facilities. So language translation, so they're talking about human languages, not computer. Symbolic algebraic manipulation, so CAS. You cannot use a CAS computer. Symbolic differentiation or integration, that normally comes with CAS. Communication with other machines or the internet. Well, this one, really, there's no way of this old one communicating. Some of the more modern machines can be connected up to USB. I assume that they do not mean that. You're not going to go in there with a cable and a computer, obviously. So during an examination, calculator must not give access to any information stored prior to that examination. Now, this is the key bit, really. So you can't have data banks, you can't have periodic table, but you can have scientific constants. This changed more recently, and I think that's why the 991 kind of Casio ended up sort of supplanting the 115 here in the UK, because the 115 was basically the 991 without the scientific constants. So now that is clearly allowed, I think Casio have decided, well, let's just stick with the 991 moniker. Dictionaries, mathematical formulae. Now this one is pretty key, and a lot of the Hong Kong approved, the HKEA approved calculators will have built-in mathematical formulae. That's not a problem for that board. UK, no, you cannot store mathematical formulae. Now, interestingly, there are a number of sharp scientifics which can store formulae. I mean, there are lots of calculators that do, and it stores it when it's switched off and switched on again. The key thing is that you must not have information stored prior to the examination. So, same for text. So essentially, if you've got something that can store any of this kind of data, it needs to be cleared before the examination and shown to be cleared. That would be my reading of it, because obviously this is a programmable calculator. And actually, it doesn't explicitly outlaw programmable calculators or graphing calculators, but it does say that you cannot have access to stored information during the exam. You can't borrow a calculator. So it talks about some calculators have an exam mode. They're basically saying if it becomes compliant in the exam mode, then that's okay. An Invigilator may give a candidate replacement calculator. That'd be pretty bad. And it mentions other things here. And that there's a series of FAQs as well, which kind of goes into the detail about this a bit more. You can take more than one calculator as well into the exam. So yeah, I did actually write to JCQ and ask them, would something like an HP-11C or a 15C be okay for the use in UK GCSE exams and similar? And they wrote back, they kind of basically said, look, we don't make decisions on specific calculators, but by the sounds of it, as long as you can clear it and it can be shown to be cleared, then in theory, yes, but you should really check with the board that are awarding your examination. All right, so that's that out the way. So yes, I think in theory, these kind of calculators are okay. But you would have to, so to clear this one, for example, before the exam, you'd switch it to, you can see there's a program in there already. I mean, it's not very useful information, but it could be, I guess, if it's a program, but you shift clear and then your program is clear and you can show it to be cleared. There we go. Okay, let's have a look at this then. So this is an online example maths paper. 1 hour 30 minutes. Let's see if you can see all of that. So let's have a look. Calculators may be used on this one. This is a calculator exam. Interestingly, if your calculator does not have a pi button, take the value of pi to be 3.142, which is so pretty low expectations for the calculator. Show all you're working out. This is a key bit, really. There are some questions in here where you might think that using a more modern calculator and some of the more modern features, particularly on the advanced calculators, would help, but maybe not. So let's have a look. Let's just go through them. Now, I'm going to kind of skip out ones where you don't really need a calculator, if that's all right. But I'll show you the ones where they're kind of, it's useful. So Frank, Mary and Seth shared some sweets in the ratio 4, 5 and 7. Seth got 18 more sweets than Frank. So Seth got a ratio of 7 to Frank's 4. So I was calculating this. I haven't actually checked if my previous attempts at this were necessarily correct. 7 minus 4 is 3, 18. So this is, if you're not familiar with RPN, essentially you've got a stack X, Y, Z and T. And so I put numbers onto the stack and I shuffle them around. Seth gets 18 more sweets than Frank. I've already calculated the difference between the ratio 7 to 4. So I'm going to swap them around. So now 18's up here, divided by 3, that's 6. So that's a ratio of this ratio to how many they've got in total. So if I add up 4, 5 and 7, so 4 and starting another calculation here, 5 plus is 9, 7 plus, so adding up that, and I know that my multiple's up here and I can double check it there, it's 6, I can hit times, work out the total number of sweets they shared, so that's 96. One thing that's quite nice about RPN is that you can essentially, you know, I get all the intermediate results. You can see there's 3 marks for this. So it's 7 minus 4. So 7 minus 4 is equal to 3. And then 18 divided by 3 is equal to 6. And then 6 times 4 plus 5 plus 7. And then 4, 5, 7 times, and you got 96. So, you know, it's quite good for showing you're working. I may not do that for all of these. Okay, let's have a look at the next one. Work out the size of the angle marked X. Give your answer correct to 1 decimal place. So, SOHCAHTOA, opposite hypotenuse. So that's sine. So the sine of X is equal to the opposite divided by the hypotenuse. It was 5 divided by 14. So 5 divided by 14. I'm in degrees mode. So it's sine, so inverse sine of that. And we've got 20.9. Did you see how long it takes? A good second to calculate that. So yeah, so sine to minus 1 of 5 over 14 is equal to 20.9 degrees. Okay, cool. All right. Oh, done that one. Here are the first 4 terms of an arithmetic sequence. Got that one in there. Write an expression in terms of n for the nth term of this sequence. This isn't really a calculator one, but that's 1, 2, 3, 4, 1. So the difference is 4, so it's going to be 4n plus 2 to make it up to 6. Yeah, it's not a calculator one there. Okay, the nth term. Sorry, I keep going off the top of the screen here. The nth term of a different arithmetic sequence is 3n plus 5. Is 108 a term of this sequence? 108, is it equal to 3n plus 5? Now, and then presumably n is an integer. So we can, by the way, I did not clear the calculator there. It's one of the things that the HP manual tells you repeatedly. Don't clear it, you don't need to. 5, I'm going to subtract 5 from both sides, so 5. Sorry about that. I ran out of space on my phone. Right, let's carry on. Let me just zoom in again. Yeah, so I'm not really answering these questions seriously, if that makes sense. I'm not trying to get all the working out marked. Right. Axel and Lefner driving along a motorway. Let's have a look at this one. There we go. They see a road sign. The road sign shows distance to junction 8, average time, speed limit 70 miles an hour to junction 8, 30 miles in 26 minutes. Lefner says we'll have to drive faster than the speed limit to drive 30 miles in 26 minutes. Right, so 30 miles in 26 minutes, so 30 miles. So we can do 0.26 and convert that into hours. We have that ability. Divide it, and it's 69.23. So we'll probably give that answer 69.2, rounded to 1 decimal place. You do not have to drive faster than the speed limit. There we go. Let me even write that one. Okay. Question 5. The table shows some information about the foot lengths of 40 adults. Write down the modal class interval. That's that one, which is that. Okay, calculate an estimate for the mean foot length. So I think you do this by taking the middle of each of these and multiplying it by that. So 17.3. 19 times 6, add them together, 21, 10 times, add it together, 23, 12, add it together, 25, 9, add it together, 40 adults, so divide that by 40 and we got 21.9, which seems sensible. Yeah, 21.9 centimetres. Now, I haven't shown my working out. You would have to do that if you're doing the exam properly. Okay. Triangles ABD and BCD are right angles. Work out the value of x. Give your answer correct to 2 decimal places. So it's a bit of Pythagoras here. 10 squared. You can just hit enter and hit times to square stuff quickly. Going to subtract the square of this side, and that should give us the square of this side. 4, square that and add it to that one, and then if I take the square root of that, I should get this side. So 9.54, and it's already in 2 decimal places. Excellent. I haven't shown my working again, but I got all the intermediate values to get the 4 marks there, so that is convenient. Or a graph. Write down the coordinates of the turning point of the graph. Let's skip this one, it isn't really a calculator one. In a box of pens, there are 3 times as many red pens as green pens and 2 times as many green pens as blue pens. For all the pens in the box, write down the ratio of the red pens to the number of green pens to the number of blue pens. Okay, 2 times as many green pens as blue pens, so 2 green to 1 blue, and then 3 times as many red pens as green pens, so that's going to be 3 times 2, which is 6. 6 red. Don't know if that's what they want. No calculating here. This one is you got a rectangle and a trapezium, and all measurements are in centimeters. The perimeters of these 2 shapes are the same. Work out the area of the rectangle. All right, well, let's just do that. I'm not sure we really need the calculator for this one. So it's going to be 2 times 3x plus 4 plus 2. I'm going to make a mistake here, aren't I? And then that's meant to be equal to all the perimeters around here, which is going to be, so 2 lots of 5x plus x minus 3 plus 7x minus 3. Okay, hopefully that's right. So let's expand it out. So 6x plus 8 plus 8x is equal to 10x plus x minus 3 plus 7x minus 3. Let's gather up the terms. So 10 plus 1 is 11 plus 7 is 18. Why did that take? Why is that set? Yeah, that's right. Yeah, 18. There we go. 18x minus 3 minus 3. So that's minus 6. On this side, 8 plus 6, 14x plus 8. Right, so let's subtract 14x from each side. So we've got 4x here. And then let's add 6 onto each side. So 8 plus 6 is 14. And therefore x is equal to 14 over 4. Could keep that as a fraction, but there we go, yeah, 3.5. And then it says work out the area of the rectangle. So that's this one here. So it's going to be 3x plus 4 times 4x. So I hit enter again there just so I've got a spare 3.5 above. Let's do 3 times that, 4 plus. That's this term here. And then 4 times that, times it, 203. Hope that's right. 203 centimeters squared. All right. I bet I've made a mistake somewhere there. Okay, let's have a look at this one. Oh yeah, now this one's a bit trickier. Katie invests 2,000 in a savings account for 3 years. The account pays compound interest at a rate of 2.5% for the first year, X% for the second year, X% for the third year. So the same rate in the second and the third year. There's a total amount of £2,124.46 in the savings account at the end of 3 years. Work out the rate of interest in the second year. Okay, so 2,000. We're going to add the interest for the first year, so 2.5%. So 2,000, 2.5% is 50. Add it, and you've got 2050. So it's going from 2050 to 2124.46. Right, so for the formula, so for compound interest, it's going to be 2050 times 1 plus the interest rate to the power of n, which is 2 payments, is equal to 212446. So what we can do, we can divide 2124.46, 2124.46, divide that by 2050, .04, take the square root of that, and then subtract 1 away from that. And so, oops, what did I do there? Sorry. I've got this answer here on fixed 2, so I'm just going to change that to fixed 4. Yeah, so it's 0.018 times by 100, yeah. Yeah, basically 1.8%. Okay. Katie goes to work by train. The cost of a weekly train ticket increases by 12.5% to 225. Work out the cost of a weekly train ticket before this increase. X plus 12.5%, which mathematically is 1 times 1.125 is equal to 225. So fairly easy, 225, 1.125, divide it, and it's 200. Okay. S and T are points on the circumference of a circle, centre 0. PT is a tangent to the circle. SAP is a straight line. Angle OPT is equal to 32 degrees. Work out the size of the angle marked X. You must give a reason for each stage you're working. All right, well, so I'm going to work out, what we're going to do is work out this angle. So 180 minus 90 plus 30 plus 90 is 122. Subtract it from 180, so this is 58. And you've got another 180 that you need to subtract from that, is 122. And then 180 subtract from that again and divide it by 2. So 29 degrees. Hopefully that is right. I should really check them. A and B are two sets of traffic lights on a road. The probability that a car is stopped by lights A is 0.4. If a car is stopped by lights A, then the probability that the car is not stopped. All right. Probability that the car is stopped by lights at A is 0.4. So 0.4. If it's stopped by the lights at A, then the probability that the car is not stopped by lights B is 0.7, and therefore this is 0.3. this one must be 0.6. If a car is not stopped by lights A, the probability that the car is not stopped by lights is 0.2. This is confusing. Hopefully I've got that right. Mark drove along this road. He was stopped by just one set of traffic lights. Is it more likely he'll stop by lights A or by lights B? So he either took this route or he took this route. So 0.4 times 0.7. So this is getting stopped at lights A is 0.28, and the chance of getting stopped by lights B is 0.6 times 0.8, 0.48. So if we stop by lights B, it's probability of 0.48. If we stop by lights A, it's probability of 0.28. So he was more likely to be stopped by lights B. I haven't shown my working. Okay, D is inversely proportional to C. When C is equal to 280, D is equal to 25. Okay, so sounds like this should be fairly easy. 280 inverse. So how much do you have to multiply that to get to 25? Oh no, that's not, I hit the wrong button there. Let me try that one again. 280 inverse 25, swap them around, divide it, 7,000. Okay, so find the value of D when C is equal to 350, so I'm just going to do that, multiply it by 7,020. Okay, prove algebraically that that is an even number. I'm not going to do that. I actually, I'm not even that confident I could do it. Prove algebraically that the recurring decimal 0.25 is the value 23 over 90. Okay, so it's not, this one isn't a, this is not a calculator question. So I guess we, this is one of these ones where you kind of shift amounts over, and I can't quite remember what it is. 0.25 recurring. So if you multiply that by 10 times 10, you get 2.5 recurring. Does that help me? And then, oh God, I can't. So I can't quite, no, I can't remember how you do these. Can you subtract them? Something about subtracting them. Not sure that helps. All right, let's skip that one. Show that this simplifies to that. No, not a maths one. Not a calculator one, sorry. Here's a calculator one. All right. Diagram shows a sector of a circle of radius 7 centimeters. Work out the length of arc AB. Give your answer correct to 3 significant figures. So 40 degrees as part of a circle, 360. So that's that proportion of a circle, which looks like 1/9. 2 pi r is the circumference, so r is 7 times 2 times pi, and then multiply that by that fraction. No, something went wrong there. All right, 40, 360, so it's 1/9 there. 2 pi r, what went wrong there? So 7 is pi times 2, and then times that. Oh, maybe that is the answer. 4.89 centimeters. Okay. Yeah, these are not drawn to scale, but I'm kind of still thrown because it looks like it should be bigger. Oh, this one about bounds. By considering bounds, work out the value of m to a suitable degree of accuracy. Right, so S is 3.47, so that means to 3 significant figures, so it's 3.465 to 3.474 is the range, and then T is 8.132 to 4 significant figures, to 8.1315 to 8.1324. So, okay, if we're going to get, so let's work out what the biggest number can be. That's going to be the biggest value of S, which is 3.474, square root that, divided by the smallest value of T, and then we got that value there, 0.2292. And then let's get the smallest value of M, which would be the smallest value of S, 3.465. Oh, I did not mean to do that. Let's roll that down, square root that, and divide it by the biggest value of T, 81324, divided by T, 0.289. 0.2289 versus 0.2292. So give it to a reasonable degree of accuracy, so it's 0.23. And then the last one, a frustum is made by removing a small cone from a large cone, as shown in the diagram. The frustum is made from glass. The glass has a density of 2.5 grams per centimetre cubed. Work out the mass of the frustum. Give your answer to an appropriate degree of accuracy. I'm not showing this to you at all, sorry about that. There we are. They've given you the formula here, and they've given you some measurements. So, should be straightforward. Let's just work out the volume of the big cone here, and we'll subtract the small cone. So volume of cone is this. So the radius is this divided by 2. 12 divided by 2, square it, times it by pi, times it by the height, which is 15, times it by a third, 1 over 3 times. So that is the volume of the big one here. Let's just double check that. 12 divided by 2, so that's the radius, 6, square it, times it by pi, times it by the height, times it by a third. Yeah, same value, 565 about. So then this top bit here, well, this is 10 centimeters, so 15 centimeters minus 10. I mean, obviously you can do this in your head, but maybe on some questions you can't. So that's 5 centimeters, and then the radius is going to be 5 divided by the height of that, because it's going to be scaled down. So it's a third. It's a third of what this was, which was 6. So it's 2. So the radius is 2 here. So we've got 2 squared times pi, times it by the height, which was 5, times it by a third, and we got 20.9 at the top. Now we should still just have the full one here in the Y register, so I'm just going to subtract that, and now we've got this frustum, or however you pronounce it, and then you've got a density of 2.5 grams per centimetre cubed, so just times that by 2.5, and there we have the weight of it, which should be 1361 grams, or probably about 1.4 kilograms. Okay. All right, so I did skip out some of the questions there. So yeah, I don't know if that was useful or not, but I thought it would be a bit fun to do it. And basically, my conclusions are that number one, there is no theoretical reason that you can't use one of these RPN calculators for GCSE. You just have to be able to prove that you can clear the calculator because it's programmable. Before the exam, you can't take anything in on it. Secondly, is it capable for doing GCSE calculator paper? Yeah, there's absolutely nothing there that a calculator like this can't do. And this is the 11C, so it's not even the 15C. You know, basically, yes. It looks like, at least on these examples, there's nothing that you can't do with this kind of calculator. It may not apply for A-level, but I might look at that on another video. Thirdly, is it a good calculator to use? Well, I think it is. This is a real joy to use. It's really enjoyable to it's got lovely clicky buttons. You can see how easy it is to just put the numbers into here, shuffle them around, get your answer. You get all the intermediate results, so that makes sure that you can show you're working, and also kind of make sure that you're sense checking it as well as you go along. Yeah, so actually I think this is a really good calculator. The number of key presses that you need to do to solve these is less, there's no doubt about it, it's less than any kind of algebraic. I've shown that on some other videos. So it's kind of quicker as well. Yeah, so that's it really. I don't think I've got anything more to say about it other than you could use this calculator for GCSE Maths, I think. Okay, bye.